up, guys? So this is lesson 9.3, and we're going to be doing probability with area. So basically, we just did theoretical probability and we did experimental probability with our total outcomes we want, or desired outcomes, over the total outcomes. So we're basically doing the same thing, but with area. So we're doing it with a physical space. So like if I'm throwing a dart at a target, or I'm basically trying to throw something and hit a target, what's the probability of me hitting that target? So I'm using the area to find that probability, okay? So right now, let's go ahead and jump into that. So probability with area, what it tells me is calculating the likelihood of an event occurring with formulas without conducting an experiment. So basically, whenever I'm doing with area probability, I'm dealing with theoretical probability. So basically, what is the probability of me hitting that target before I throw it, okay? So just like there's a place in Waco where you can go throw axes at a target, what's the probability of me hitting that piece of that target, okay? So remember, I'm doing the probability of A happening is I'm doing the total area of what I want over the total amount of area of that space. So let's go ahead and take this information, or take this idea, and let's apply it to our examples. All right, so let's go and look at example number 1. So on example number 1, it tells me if a dart is thrown at random and the diameter of the blue is 10 inches, the diameter of the yellow is 6 inches, and the diameter of the red is 2 inches, we need to find the probabilities. So right now, let's go ahead and figure out, if I was to throw a dart at this target, what would be the probability of me hitting the red? That's what I'm looking at. So I'm comparing their areas. So remember, I have to do the total area on bottom. So I know from side to side, all the way across, the diameter is 10 inches. So the area of a circle is going to be pi r squared. So the total amount of space is going to be pi times the radius, which half of that is 5, squared. Now I have to do the area of my red circle. So it says right here, the diameter of the red is 2 inches. So that means the radius is going to be 1. So I'm going to do pi times 1 squared. And whenever I type this in the calculator, it's actually going to give me 0.04, which if I move that 2 decimal places over is going to give me a 4% chance, a very small percent chance that I'm going to hit that target right there, okay, just by the area. Let's go ahead and do the yellow. So right now, if you look, the yellow is inside right here, okay? So that means in order for me to find just the yellow, I have to take out the red from the yellow. So again, I know the total amount of space here, and I'm actually going to do a different color here. The total amount of space again is going to be pi 5 squared, okay? Now remember, I told you I have to take the area of the yellow, so I'm going to do pi, and then the radius of my yellow is going to be 3 squared, and I have to subtract out the area of the red. So whenever I type this in my calculator, remember I did yellow minus the red to get just the yellow. And whenever I type this out in the calculator, it should come out to be 0.32, which if I move it 2 decimal places over, will turn into a 32% chance that this is going to happen. So there's a 32% chance that I'm going to hit the yellow part instead of the red, okay? It's a higher percent chance than the red, okay? So now we're going to find the probability of not blue here. So that means I'm taking just the area of the yellow and red. So the area of the yellow and red here, I'm going to take the radius of my yellow, which is 3. So I'm going to take pi 3 squared, and I'm going to divide it by the total area of my circle again. So whenever I divide this, it's going to end up giving me 0.36. 2 decimal places over will give me a 36% chance of me hitting anything but blue, okay? So this is how you take the area and apply it to find the probability. So let's move over to example number 2. All right, so on example number 2, it says, what is the probability that a ball thrown at the target will hit the shaded area, okay? So that means I need to take the total area. So the whole target looks like it's going to be a rectangle. So if I want to find the total area of a rectangle, I'm going to do base times height. So on the bottom, I'm going to do the base times the height. So I'm going to do 8 times 6 on bottom. That's going to be my total area. Now it looks like I want just the area of the shaded region. So that means I need to take the total area of my rectangle, and I need to subtract out my circle. So I'm going to subtract out, it looks like the diameter is going to be 6 all the way across. So half of that is 3. So I'm going to take out pi 3 squared. So whenever I work this out, work it out on my calculator here, it's going to end up giving me a 0.4109, which if I do 2 decimal places over is going to be a 41.09% chance. Okay, so less than a 50% chance that when I throw a ball, it's going to hit the shaded regions of my target. Okay, so that's the probability of that. Moving on to example number 3. Okay, so on number 3 it says, what is the probability of hitting one of the triangle targets? So remember, we're doing what we want on top and then the total on bottom. So my total target is going to be the whole rectangle or square here, right? So that means on bottom, I have to take the area of a square, which is going to be base times height, which is 13 times 13. And now I got to figure out the area of me hitting the triangle. So what I want to hit the 2 triangles. They're congruent triangles, so I have to do 2 times the area of a triangle. So 1/2 the base times the height, which is 5. So this is what I want on top. So whenever I work this out, what I want on top and the area of the whole thing on bottom, it should come out to be 0.1035, which if I move it 2 decimal places over is going to be a 10.35% chance. So about a 10% chance that if I throw something and hit the 2 targets, there's going to be a 10% chance that I'm going to hit those. Okay? Looking at example number 4. All right, and last on example number 4, we have, it looks like a spinner here, and we're trying to figure out the probability of landing on some certain colors. The one thing that was not added here was the radius of my circle. So I'm going to go ahead and tell you the radius. I'm going to add it here. Your radius is going to equal 3. Let's go ahead and work with that. So the first one it wants is the probability of landing on green. So remember, I want the area of what I want over the total area. So I know the total area is going to be pi times the radius squared. So that's going to give me the total area. So now I got to find the area of what I want. So the green area has a degree measure of 170. So I'm going to take the total area of my circle and I'm going to multiply it by the ratio of 170 over 360. Because that's going to give me the area of that sector. So I'm taking the area of the green sector over the total area. And when I work that out, it's going to end up giving me 0.4722, which if I move that decimal place over 2 times is going to give me 47.22%. So that means there's a little less than a 50% chance that I'm going to hit the green when I throw it. Okay? And now lastly, it says, what is the probability of the spinner not landing on yellow? So I don't want yellow. That means I want either green or purple here. So I'm going to do the same exact thing. So I'm going to do the total area on bottom, and I'm going to do the area of what I want on top. So that means I have to take the total area, and I have to multiply it by 170, and 100 gives me 270 over 360. That's going to give me my sector area over the total area. So right now, whenever I work that out, that's going to give me 0.75, which in turn is going to give me 75%. So that means there is a 75% chance that when I spin this spinner, that it's either going to land on green or purple, not yet landing on yellow, okay? So remember, you want to make sure you do what you want on top, so the total area of what you want on top desired, and then the total area of the whole shape on bottom. And when you divide that, it's going to end up giving you the probability of that happening, okay? So let me know if you need help on your skill check. Good luck on your skill check.